In Bellingham, Washington, we did an experiment with diesel and oil-saturated soil. 2% of the soil was actually hydrocarbons. 4 companies were called in to do experiments. There's one control pile. One pile was treated with bacteria, one pile was treated with enzymes, and then the 4th pile was treated with our mushroom mycelium. The mushroom mycelium absorbs the oil. Now it's producing extracellular enzymes called manganese peroxidases and cellulases that break carbon-hydrogen bonds. These are the same bonds that hold hydrocarbons together. So the mycelium at first absorbed the oil. It became black in color. And then the oil was then denatured. We came back weeks later, and our pile was covered with hundreds of pounds of oyster mushrooms. Some of these mushrooms were up to 16 inches in diameter, a testimonial to the nutrition that the mycelium was able to gather by breaking down the diesel-contaminated soil. The 3 other piles were dead, dark, and stinky, and lifeless, and our PAHs, the polycyclic aromatic hydrocarbons, went from 20,000 parts per million to less than 200 in 10 to 12 weeks. The other control piles did not. They remained at their resident levels. Something else occurred that was a great epiphany for me. I watched the mushrooms rot. And as the mushrooms sporulated, they attracted insects. Insects came in that laid eggs. Eggs developed into larvae. Birds came in after larvae. They brought in seeds. And our pile became an oasis of life. The other piles were dead, dark, and stinky. These fungi are gateway species leading to habitat restoration.